Hello everyone, I'm Shweta from CSC final year. My roll number is 212222404167 and my guide Dr. V. Umarani, Associate Professor, Department of CSC. And in the first slide we have introduction statement and just all like agenda. We have set nine topics in the agenda. And now we come to the introduction. With the growing rate of interconnections among computer systems, a network system is becoming a major challenge. In order to meet that challenge, intrusion detection system protects the availability, confidentiality, and integrity of informed systems. Automated detection and immediate reporting of intrusion events are required in order to provide timely response to attacks. In this project, network-based anomaly detection method for detecting denial of service and network probe attacks is done. In anomaly detection, the normal behavior of the system is modeled. Incoming patterns that deviate sustainability from the normal behavior are labeled as attacks. And now, in the next slide, we came to the statement of the problem. It's the task is to build a network intrusion detector, a predictive model capable of uh, distinguishing the bad connections in between and calls intrusions or attacks and good normal connections. In this, to develop a technology that deny of probe attacks. We use the IDS collect network traffic information from the point on the network and this use information to secure the network. In these rules can determine of intrusion characteristics and then to implement in the genetic algorithm. And now, scope. The primary purpose is to build a machine learning model network to detect the traffic for suspicious activities and patterns that may comes from unauthorized access and for other social threats also. IDS can identify deviations from normal behavior, helping to detect the previous unseen threats and abnormal activities. A methodology. In this intrusion detection system using machine learning, is a software application to detect network intrusions using machine learning algorithms. It monitors a network from the activity and protects the computer network from unauthorized access from the users, including perhaps insiders. It is a task to build a predictive model and capable of testing between the bad connections and good connections. In this, we use machine learning algorithms like genetic algorithms, decision trees, and heuristic algorithm, and the data collection, like features, data collection, data pre-processing, feature selection, and we use U2R unauthorized access, probing, surveillance, anothering probing, and R2L unauthorized guessing passwords, and all. And here is the block diagram. You can see NSL set first goes to the data pre-processing and divides to genetic algorithm to optimize and then it's go to the training phase decision trees and IDS learning, and from the in the other hand it goes to the performance detection and intrusion classification and do's and probes or can be tested easily. And the flowchart diagram as follows: a data set to data processing, feature selection, testings, training models, and at last it goes to the classification algorithms and predicting network attack category. Is it a good connection or bad connection? In this, we came to in this project we came to the result. First, we should train it successfully, and we should get that log, like just we should test the static testing from the training model as well as KDD, and if we plot the graph we get the normal as above 120 count. If 2 means we'll get the greater count. In conclusion, in this project a genetic algorithm along with the decision tree project is deployed to intrusion detection system. Genetic algorithms are employed to the classification rules for the intrusion detection system. And the proper attack and the proper training dataset exist. The classification of attacks is important in intrusion detection system. gives the facts so that they can be retained before bringing out from any damage. And the protocol type we notice is that is the most recent user data, that TCP or that protocol, and UDP type also. And future with higher attack detection rate and low false positive rate are the advantage of using this technique without using any complementary techniques that is commonly used with the soft computing techniques. And so it can perform intrusion detection process faster, and it could be applied to high speed networks also. And I took these references to complete this project. And yeah, we move to the execution part. We go to the first the PyCharm. Yeah. And now we have the folders like decision tree, individual by packet, preprocessors, classifier. And first we move to the class and we run this. If we run, it will run. It takes time to execute. We will wait until it gets run. Yeah, we got this right. We have in this folder we have in the left corner intrusion detection and file about. And in this folder we first need to train the model first. If we click the train model, it loads, and now we move to the data set. Okay, in the data set we take all attacks first. First we need to determine whether the log is in which category, is it the bad connection or the good connection. So we open that. Again we move to the all normal and open. We got the model trained successfully, right? Then we should click OK. Now static testing. Again all attack, open. See, now here is the log. It's coming, and we should stop capture. It's running, right? Now we should stop capture and plot the graph. I told you, no? 2s will be above 17.5 of that count. Okay? 17.34. Now we will go to the static testing. Please remind that 17.34. And now all normal, open. See, the log was coming, right? We should stop capture and plot the graph. Now, the dose will be 12.19. Okay. Now again, train model, KDD test. Again open. Again KDD test. The model trained successfully, right? Now again, static testing. Again KDD test. Open. You can see the values are coming right now. We will stop capturing and again plot graph. You got the normal value would be 80, which is y 53.0. At the first time we got 17.3 and 120, about 120. And now you can see that 54 point or this 81.6. The maximum value of the normal case is 81.6, and dose it will be 5. Okay. Now again we move to the static testing. We completed first three, and now we go to the KTT train plus. And we if we open this, we will get the values coming from the testing. See, you got the values, right? Now stop capture, plot graph. Again, you can see here it's 19.6. And that's all. It's the execution part. Visualizing categorical features using bar graphs. Okay, we use the ICMP and TCP protocols, and the code correlation and all we can get easily. In the train score, we got exactly 97% approximately. This project in detecting the good connections and bad connections. It's just a train score is zero point 0.9, test score is zero point 0.9. And we have the bar graphs in NBT, TRF, and SPML, RGB, and all. And thank you. This is the final part of execution. And thank you.